Okay, so for today's lesson, the focus will be conditional probability. So I hope that after these 30 minutes, you can have a better understanding on conditional probability that is actually not very difficult to solve it. And actually, you are doing a lot of conditional probability that you guys might not realize it. Okay, so I hope that this lesson I can clarify some of the question or doubts that you guys have, and I try to guess what is the part that confuse you guys. So hopefully after this session you can have a better understanding about this topic. So feel free to let me know like whether this 30 minutes is helpful for you or not to understand it. Okay, so before I move on to conditional probability, right, I want to talk about independence first. Okay, so whether the event is independent or not is going to be like very important to conditional probability, and this is how conditional probability comes in also. Okay, so when we talk about independent event, actually we are talking about you have two events that the occurrence of either one is not going to affect the other one. So meaning whether A happens or not is not going to affect B. Okay, so let's try to do a very simple example. Let's use the example that we used previously in the handout. Okay, let's say if I have a box, then inside the box I have like 3 red ball and also I have 5 blue ball. Okay, so now I have two different scenarios here. So the first scenario is I will try to pick 2 with replacement. So the second scenario is I will try to pick 2 balls without replacement. Okay, so this is without replacement. Okay, so now I think you know how to do that. Let's say if I want to draw a tree diagram of these two scenarios, how am I going to do that? Okay, so with replacement, then you will realize that it's like very easy. What I will do is the first one, the first pick, the first selection, then it will be either red or either blue. So the probability for you to get a red will be 3/8, for you to get a blue will be 5/8. Because I do it with replacement, I'm going to put the ball back into the box itself, then after that I only pick the second one. So I have the same amount or the same quantity of ball in my box when I pick the second ball. So it will be the same thing, which the second one is red, or blue. So it will be 3/8 as well and 5/8 as well, because I do it with replacement. So the same thing, no matter the first one I get it a red or a blue, even I get it for a blue one, the probability for me to get a red is still 3/8 and for me to get a blue is still 5/8. Okay, so looking at this scenario, what you can realize is if I'm going to continue the experiment with like 3rd time, 4th time or so on, I will realize that for every stage, right, I will have the exactly same probability. So meaning like you can see 3/8, 5/8. When I try to do the second time for the second stage, what happened is going to be 3/8, 5/8. Then if the first time I get it the ball, then it's going to be I get a blue one. For me to continue, it's still going to be 3/8 for me to get a red one and 5/8 for me to get a blue one. So for this scenario, actually this is what we call as independent. So meaning I don't care what happened previously, it is not going to affect what happened next. Okay, so this is independent event. Okay, so you must remember for every stage, no matter what happened previously, it is going to be the same for the second, third, fourth, and so on. Okay, how about without replacement? So without replacement, then what you can realize, you will realize that the first time when I do, then it will be red and then blue, then it's still the same 3/8 and 5/8. Then after that, what happened? When I try to move on to second stage, because I do it without replacement, what I got for the first stage is going to affect my second stage. So meaning that if the first time I get a red one, then how many red ball do I still have inside the box? I left with 2, correct? Then after that, because I take 1 out already, the total number of ball inside the box now becomes 7. So because the first time I get a red one, so the blue one I still have a 5 with total 7 of the ball. So B. Then after that, I continue with R. So if the first time I get a blue ball, then the second time the probability for me to get a red ball will be I still have 3 red ball, then total 7. So if the first time I get a blue ball already, then I do not have 5 anymore. I have 4 now over 7. Okay. So what you are doing now is actually conditional probability already. What does that mean? You see, if I try to rephrase what I'm saying just now, what is this 2 over 7 means? 2 over 7 here basically meaning that given that the first ball I pick from the box is a red ball, the probability for me to get a red ball in the second selection is going to be 2 over 7. I repeat again, maybe I do it for the blue ball. Okay. Given that, because you guys always remember like this, like conditional probability is like given that something blah blah, then you find the probability for the other one. Okay. So this is 5 over 7, right? Okay. What is 5 over 7? Isn't it 5 over 7 is the probability for me to get a blue ball given that I get a red ball at the first stage? You get my idea? So meaning that you do not try to memorize the conditional probability like it must be like A intersect B then divide by probability B. So it is actually something that like very easy to understand and it's something like very logical. Okay, so continue with this. Okay, you remember that you have a lot of, I write it down first. So this is the not independent one, meaning that what happened after that is going to be affected by what happened previously. So what is this called? This is actually called conditional probability. Okay? Alright, so now you see there are a lot of questions that you go through before in your handout. Okay, so I think what confuses you is maybe I skip the first basic part. So we solve a lot of questions that is like they give you in terms of okay, it's okay. Later we'll go through the example again together. Okay, but now I want you just to remember this in your mind. For independent, it's going to be like what happened previously is not going to affect what happened next. So meaning that, for example, okay, you see, let's try to do a simple illustration now. Okay, I hope that you can understand this already. Okay, independent, what happened previously is not going to affect what happened next. Conditional, what happened previously is going to affect what happened next. Okay, so now you see this. We have a lot of scenario like this, so maybe let me do a very easy one. Okay, so because just now we talk about the same thing, so maybe it will be like very hard for you to like see the difference because we are talking about the same action, like picking a ball from a box. Okay, now let's try to do different scenario now. Okay, if now let's say that I'm talking about rain or not rain. Okay, then the second thing is I talk about whether I walk to school or I not walk to school. Okay, what is that mean by these two scenarios are independent? Your tree diagram will look like this. Okay, this is for independent. Okay, maybe I have 30% that is going to rain. 70% not raining. Okay, after that, what is that mean by these two are independent? It goes like this. I walk to school, I not walk to school. I walk to school, I not walk to school. If independent, it means that for raining day, the probability for me to walk to school is 40%. Then the probability for me to not walk to school is 60%. If it's not rain, the probability for me to walk to school is still 40%. The probability for me to not walk to school is still 60%. Can you see that? This is independent. So meaning that no matter what happens, no matter it's raining or not raining, the probability for me to walk to school is 0.4. The probability for me to not walk to school is 0.6. It's going to be the same. So that's why you will continue with like the probability that is rain and I walk to school will be exactly equals to probability for me to rain and for it to rain and for me to walk to school. Because what happened, you can see that probability for it rain is 0.3. Probability for me to walk to school is 0.4. So they are independent. So we can straight away like times them together 0.3 times 0.4. Because no matter what happened previously, it's going to be the same that 40% of the time I will try to walk to school, 60% I would not walk. Okay, what is that mean by conditional? It is go like this. I have the same thing. Okay, now if it's rain, the probability for me to walk to school is like 10%. For me to not walk is 90%. If it's not rain, I have 70% that I'll walk to school. I have 3% that I won't walk to school. Oh, sorry, NW. Okay, can you see the difference now? Whether it rains or not is going to affect whether I want to walk to school or not. Okay, my question is, do you think this number is still PW? You see just now, no matter what happened, right, the probability for me to walk to school is still 0.4. Correct? So whether it rains is still 0.4, not rain is also 0.4. So the probability for me to walk to school is exactly 0.4. So now you see, the probability of me whether walk to school or not changes whether it's rain or it's not rain. So we cannot have actually like probability of, okay, so probability of rain is of course 0.3. Can we have probability of walking to school here? Am I going to take 0.1 or am I going to take the 0. Sorry, this is W. Or I going to take the 0.7 here? I cannot decide whether it's 0.1 or 0.7. What I'll need to do is I will need to add up here and I need to add up here. Because these are both probability, two scenarios that actually that I will actually walk to school. Okay. So how do I actually write the probability here? It's basically the probability for me to walk to school given that it's rain. The 0.1 here is basically given that it's rain, the probability for me to walk to school. What is 0.7 here? Is probability for me to walk to school if it's not raining. if it's raining. Yeah, correct. If it's not raining. Probability for me to walk to school, if it's given that it's not raining, is 0.7. So you see, a lot of multiplication that you are doing is actually probability for R and W to happen. It will be equals to PR times with P proper R and W R. I'm not sure you can realize this or not. So you see, if I want to find out the probability for it to rain and I walk to school, then what you will do? You will do 0.3 times 0.1, right? Why is that so? Because you want to find out the probability that both of these events is happen. And because it's not independent, so that's why I'm not going to take 0.7 here, because 0.7 is not going to happen if raining is happen. So that's why I have like R 0.3 and 0.1 here, and what you are multiplying the 0.1, the 0.1 is basically the conditional probability for me to walk to school if it's rain. So when you look at this formula, right, isn't it is the same thing if I'm going to do probability of WR equals to, if I move this, then I'll get the exactly same thing. It's like the same thing that you actually use to do the question. I mean, normally you will write W intersect R, but isn't it the same thing, like whether W intersect R or R intersect W? Then you will divide by the probability of the given that part. Okay, so this is basically called as conditional. But of course, I'm not talking about the whole process that you are doing. I'm talking about actually this part is a conditional probability. Okay, so why are you always feeling confusing is that normally in your question, right, if you have something that you have tree diagram like this, like question like whether I will get a flu if I do a vaccine or not. So question like this, then normally they will give you the probability given that you got the vaccine, then whether you got a flu or not. If you don't have a vaccine, then you got a flu or not. So they actually put everything in a conditional way that you straight away multiply them without you realizing it's actually conditional probability. But the problem of some question is that if it's not in this case, it's in the case that you need to identify your sample space yourself, then you will feel confused. Okay, now let's try to look at the example. Okay, let's say I have something like this. Okay, so again, I want you to try to learn this without memorizing. Of course, I will try to explain again everything, like how do you want to use formula, how do you want to not use formula. It will give you exactly the same answer. And I hope that I can guess what you guys did wrong in your exercise, and I try to explain it why is that wrong. Okay, so now let's try to look at few example that I guess those are the question that you get it wrong most of the time in the exercise. Okay, a letter is selected from the word ACE. Find the probability of E selected given a vowel is selected. Okay, let me try to guess what is the thing that you do. Okay, so I think you will try to do this. The probability for me to get an E given that a vowel is selected. Then after that, what you will try to do? Probability for E intersect with vowel. Then after that, you'll continue with divide by probability of vowel. Okay, then what you will try to do is you will try to do probability for you to get this, then you will try to do PE times P vowel. Oh, sorry. Then divide by probability for vowel. Then after that, what you will try to do, you might continue with something like this. Probability for you to get an E is like 1, 2, 3, so that's why you do 1 over 3. Then probability for you to get vowel, so you have AE, so that's why 2 over 3. Then you divide by the vowel, so you got 2 over 3 here, so 2 over 3, which give you an answer of 1 over 3. So this is, I guess this is what you did, which gives you a wrong answer. Okay, so now I want to try to explain why is this wrong. Okay, the idea is like this. You remember just now when we tried to do the conditional probability thing? Okay, I mean this might be not a very good way, but I just want to show you in terms of like why you are doing this wrong. Okay, you see, given that a vowel is selected, so meaning that if I'm going to represent this in a graphic, what is that look like? So meaning that given a vowel is selected, so I have two possible scenarios here. The first one is I might get a vowel. The second one is I might not get a vowel. Probability for me to get a vowel is how much? 2 over 3, correct? Which is A and E over ACE. Probability for me to not get a vowel is 1 over 3. Okay, now given that a vowel is selected, so meaning we don't care about this part lah. Okay, what if find the probability of E selected? Now you got vowel already. What is the probability for you to get E selected? You can get E or you get not E. So what is the probability for you to get E? Is 1 over 2, because vowel meaning A and E, right? So for me to get E, it will be 1 over 2. For me to not get an E, it will be 1 over 2. So my question is, if you are finding probability for you to get vowel and E, what you are doing is 2 over 3 times 1 over 2. Now look back what you have done just now. Your probability of E times probability vowel is 1 over 3 times 2 over 3. Which one is wrong? This one and this one. Why you are doing so? Because you are looking at the big sample size. So you didn't take into the consideration that if you already selected a vowel, the probability for you to get E is not 1 over 3, because you don't have a sample size of 3 anymore. You only left with A and E. So meaning that what are you assuming here is you are trying to assuming something wrong, which is like this is vowel, this is not vowel, and this is 2 over 3, this is 1 over 3. No matter I get vowel or not vowel, the probability for me to get E is still 1 over 3. Then not E is like 2 over 3. Then probability for me to get E, it will be like the same 1 over 3, and for me to not get an E is still 2 over 3. So can you see what are you assuming? It's like no matter I get a vowel or I not get a vowel, the probability for me to get E is still the same, which is not correct. So that's why if you want to do this method, then it will be this one. It should be 1 over 2. So which your last answer is 1 over 2. Okay, so can I solve this question in an easier way? Yes, without using this. The whole process here is still correct. The blue one. If I don't want to use the formula, can I solve it in common sense? Yes, why not? Find the probability that E is selected given a vowel is selected. So you want to find out the probability for you to select E given a vowel is selected. So meaning that now, what is the probability for you to get a vowel? Sorry, I rephrase my word. Okay, how many vowel do you have? Because you already know that you get a vowel, right? Given a vowel, how many vowel do you have? You have 2 vowel here, correct? So out of the 2 vowel, how many E that I can select it? You have 1. Because vowel you have A and E. Then the probability for you to get an A is like only 1. So 1. So isn't it you get the exactly same thing? So you just try to understand in a way that given a vowel is selected, so instead of a sample size of ACE, now my sample size become AE, which is my vowel. So under this vowel, within this vowel, how many E that I have? I have 1. So that's why 1 over 2. Okay? I try to explain it again. We have few examples here, so I hope that after this you can understand it better. Okay, so number 2. A child is selected at random from a group for 11 boys and 9 girls, and one of the girls is called Rose. Find the probability that Rose is selected given a girl is selected. Okay, again, I try to show and I try to guess what you did, which some of you got it wrong. Okay, you will try to do like this. Probability for you to get Rose given a girl is selected. Then what you will try to do next, then you will try to continue with probability of Rose intersect with girl divide by probability of girl. Okay, then you will do your multiplication, which you will try to do. For you to get a Rose, you only have 1 girl whose name Rose, so meaning it will be 1 over 20 people. Then you will times with probability of girl, which is 9 over 20. Then you divide by probability of girl, which is 9 over 20, which gives you an answer 1 over 20, which is wrong. So why is that wrong? It's the same thing. You are assuming that no matter, so given a girl is selected, so you are assuming that this is girl, this is not girl. So no matter I get a girl or not girl, the probability for me to get Rose or not Rose is the same, which is obviously not correct, because if I'm going to get a non-girl, the probability for me to get Rose is definitely like 0. Then for me to continue, if I already got a girl, then of course my probability will not be like 1 over 20 anymore, because I already know that I get a girl, which my sample size now become 9 already. Okay, so what is the easier way to do this? So let's try to do this. So probability for you to get a Rose, for you to get the girl whose name Rose, it will be equals to, so how many total you are looking at now? Your sample space now become girl already, given a girl is selected. So that's why for girl it will be 9. So for you to get a girl out of this 9 girl, correct, whose name is Rose, so 1 over 9. Okay, so let's see, if you want to use this method, can you do that? Yes, why not? So if you want to do that, then you must make sure that you draw the correct thing. So meaning that probability for me to get Rose, given that the girl selected is the student selected is a girl, so I'll do probability Rose girl and probability girl. Okay, so what is the probability for you to have Rose and girl? So let's try to do this. So if you get a girl, what is the probability? The probability for you to get a girl is 9 over 20. Okay, then after that, for you to get a not girl is like 11 over 20. So what is the probability for you to get Rose if you already get a girl? Then it will be 1 over, for you to get Rose, it will be 1 over 9. Because you get a girl already, what? Then that means you have 9 now. So for you to get not Rose, then it will be 8 over 9. So how are you going to continue? It will be 9 over 20 times 1 over 9 divided by probability for you to get a girl, which is 9 over 20, which give you exactly the same thing, 1 over 9. Okay, so let's try to do this again. Okay, example 3. Okay, so this one is the table form. So I will try to teach you guys how to read the table. Then after that, I'll show you again if you still want to use the formula method. Okay, the table shows the number of students who study biology and chemistry. Find the probability that a student take chemistry given that they take biology, or does not take biology given they do not study chemistry. Okay, so let's go with A first. Okay, so how do you read this table? It's basically the total students you are looking at now is 25. So in these 25 people, 17 of them take chemistry, 8 of them not taking chemistry, 16 of them take biology, 9 of them doesn't take biology. So what is the box here? This box is the student who take biology and who take chemistry. This box is the student that take chemistry but not biology. This box is the student who take biology but not taking chemistry. This one is the students who doesn't take biology nor chemistry. Okay, then after that, if I want to find out the student, let's try to do a correct one first. If I want to find the students who take chemistry given that they take biology. So how do I find that? So you remember we talked about sample size. So how many students you are looking at now in total? You see, given they take biology, so meaning that the sample that you actually want to investigate now is the biology student. So how many students take biology? 16. Correct? Given they take biology, meaning that you already ignore other, you're only looking at those who take biology because given they take biology. So what is the probability as students take chemistry? So out of these 16 students, how many students take chemistry? 9. So 9 over 16, just like that. Okay, if you want to use the formula, how can you do that? Yes, you can. So probability for you to get chemistry, biology equals to probability for chemistry intersect with biology divided by probability of biology. Okay, so the same thing. You remember the mistake just now? You cannot use that because if you use that, meaning that you are saying that no matter I get the one that from biology or not biology, the people who take chemistry is the same. But you see that it's not going to be the same. So meaning that whether they take bio or not is going to affect whether they take chemistry or not. Because if they take biology, then for them to take chemistry is like 9 people. Then for them to not take biology, then it become 8 already. So I cannot use like probability for chemistry times probability with biology. So what I will need to do, so you start with the, okay, so maybe we start with the probability of biology first. Probability for you to get someone that biology is like 16 over 25. Correct? Probability of biology. So now given that biology, so meaning that if you try to draw the tree diagram, then meaning that you are looking at biology now. So biology and not biology. So what is the probability for you to get biology? It's 16 over 25. Then after that, what is the probability for you to get someone that is biology if they take for you to get chemistry if they take biology? So it's going to be, now you are looking at the 16 people, right? Out of the 16 people, you have 9 people, which you get exactly the same thing, 9 over 16. So what you can realize here is that if you want to follow the formula, right, you will realize this part is always the same. I'm talking about if you are dealing with sample. You can realize that it's basically the same, because what you are doing now is just like looking at a smaller sample, then after that you try to come out like how many you have. So it will be easier if you can understand and try to do it in this way. But then, I mean, it's still the same. You are getting the exactly same answer, and no problem for the method if you want to use this. But the only thing that you must realize that whether you must realize about the conditional probability, which you cannot exactly use probability of chemistry times with probability of biology, which like this. Okay, so the same thing, let's do in an easier way for probability for this, not taking biology, given that they are not taking chemistry. Okay, so it will become, so you're looking at the sample size of not chemistry now. So how many students does not take chemistry? So not taking chemistry, it will be 8. So meaning other, I don't care, I only care about here. So out of here, how many students not taking biology? 1. So 1 over 8. Just simple like that. Okay, so let's try to go to the next one. Okay, yeah, I think this is the question that exists in your exercise and you got it like a bit confused. Okay, so probability that the number is obtained is prime given it is odd. So easier way to do this, then it will be probability for you to get a prime number given is odd. So what is the total sample size now? You are looking at odd, so meaning 1, 3, 5. So you have 3. So out of these 3, how many prime that you have? 1, 2. 1 is not a prime number, okay? So 2 over 3. So if you want to use the formula, then it will be probability for prime intersect with odd divide by probability of odd. So how do you guys do it wrong? It's because you take the odd number like 3, 5, then you do prime number first. So you have 1, 2, 3, 4, 5, so you have only 2, 3, 5, so 1 over 2. Then probability for you to get an odd number is like 1, 3, 5, so 1 over 2. So what you are doing is you always do like this, 1 over 2 times 1 over 2, then you divide by 1 over 2, which gives you a wrong answer. Okay, why is that wrong? Because the same thing, you are assuming that if you try to draw a tree diagram, then you will get something like odd, not odd, then prime, and not prime. You are assuming that no matter what happened previously, it is going to be the same after that, which is not correct. So what is the correct way of doing this? If you already know that you are getting an odd, so this is not odd, so it will become here, it's like 2, let's try to do the full number, so 3 over 6, 3 over 6. So since you get an odd number, so meaning now your total become 3 already, right? So for you to get a prime number, then it will be 2 out of 3. So this is how you will get 3 over 6 times 2 over 3 divided by the odd number, which is exactly 3 over 6, which give you the same thing. Okay? You see, actually this way of drawing tree diagram is like not I mean, I'm not an no, sorry, just ignore what I'm saying just now. Okay, so this is how you should check it. Okay, so the last one, let's go back to those questions that we did in the handout, which I think this one is those questions that you don't feel confusing, but I just want to explain why is that you can do it like just times them together, then you just do it. Okay, the idea is I walk to school 60% and cycle 60%, so 0.6, 0.4, walk, cycle. So 5% of the occasion that he walks and he will be late. So walks, late it will be 5%. Walks does not late, then it will be 95. So if he cycle, then he will get only 2%, which is late. Then 98% will be not late. So what you can see here, right? You see how they are trying to tell you all this. They will say something like this. Okay, he is late to the school on 5% of the occasion where he walks. So what is the 0.05 here means? It's basically the same thing like probability that he will be late given that he walked. This probability is not the probability for he walks. I hope you can get it. Because the probability for he walks is depends on whether it the 0.05 here doesn't mean the probability that he is late. This probability is the probability that he is late given that he walked. So the 0.95 here is the probability that he is not late given that he walked. 0.02 is the probability that he is late given that he cycled. So this one is not late given that he is cycle. Okay, you get the idea? So for all this kind of question, they already put everything nicely for you without telling you that actually this is what that means. So for this kind of question is that because of they didn't compute everything is in percentage and you need to find out this by yourself, and this is why you feel confusing. Okay, so for this one, if you want to find probability that he cycled to school, then it's very easy lah. Then what you will try to do, you will do he late to school, the probability that he cycle. So given that he is late, given he is late, he cycle. Probability of he cycle to school given that he is late. Okay, then after that you will try to do like this. Correct? So every time you still remember how do you find the probability that he is late, then you will need to find out all the probability that he is late, right? So probability he cycled to school and he is late, cycle to school and he is late. So 0.4 times 0.02. Okay? Then after that, when you want to find probability that he is late, then what you will try to do, you will do the late and late. So 0.6 times 0.05 and then plus with 0.4 times 0.02. Okay? So when you try to expand this and see what you will get. So you'll get 0.6 times 0.6 times 0.05 plus 0.4 times 0.02. So this is 0.038, then times with 0.4 times 0.02, which give you 0.008. Okay, you see 0.038 is the probability that he is late, right? Okay, you see whether you realize or not. What I am doing here is probability of C times probability LC. This is how I do 0.4 times 0.02. Actually, I am not doing this. This is what you guys have thought you guys been doing. You are not doing this because if you are doing this, then it's supposed to be 0.4 times with 0.038. Because this is the probability that he is late. So if you want to find the probability that he cycle and he is late, then what you will do? You will do 0.4 times 0.02. You are not going to use 0.4 times 0.038, right? because whether you are late or not is going to depend whether you walk to school or cycle to school. So that's why the L that you take, it must be consistent from the one that happened previously. So like this one, you already know that you cycle and you are late. So that's why if it's cycle, then it's 0.02. If you are walk, then you only use 0.05. So that's what is that mean. Okay, so I hope that after this you can try to like really understand what is the problem that makes you guys confused, and hopefully you can understand everything. So let me know whether this helps you or not, and I think that's it for this lesson. So I'll try to like upload some revision video or some clarification video like this also. Okay, so alright, so I hope that you can understand. Thanks for watching.